Welcome, ladies and gentlemen. My name is T.C. Kao. I'm a professor at the Rail Transportation and Engineering Center at University of Illinois at Urbana-Champaign. Our subject today is about the construction methods for high-speed rail system. Again, due to the time, we will not be able to give very detailed introduction of all the construction methods for high-speed rail system. This will be an overview of the construction methods used for high-speed rail system. Again, this is a subject of one of the high-speed rail class in our Railroad Transportation Center. To put the subject into perspective, let's try to start with the curriculum which we are teaching, the high-speed rail curriculum we are teaching at the University of Illinois at Urbana-Champaign. There are 4 high-speed rail classes we are teaching at the University of Illinois at Urbana-Champaign. Among these 4, one is on the high-speed rail engineering, and one is on the planning, and one is on the construction management, and another one is on the maintenance and operation. Today, the subject we want to talk about is a subject, or it's a topic which is included in this high-speed rail construction management. It's the third class we have on the high-speed rail system. This subject we will be discussing in many topics. In this class, we discuss about the overall construction method for high-speed rail system. Then what we did is we go into the managing the scope of the project, managing the schedule of the project, managing the cost of the project, and management the quality of the project, and risk and procurement and interface, and so on and so forth. So that was the subject. Our topic today is the first one of the previous the previous slide, which is on the overview of the high-speed rail construction methods. In this one, we talk about the high-speed rail construction, how to construct a high-speed rail system. Before we do that, maybe what we should do is to look at how high-speed rail system is unique for its construction characteristics. So what are these characteristics? What is high-speed rail system construction different from other systems? First of all, we can see that high-speed rail system is a mega system. A high-speed rail system usually including considerable length of the project, otherwise the train cannot run high speed. So usually it will be 100 miles or to 300 miles, or let's say it's about 200 kilometer to 500 kilometer in size. In its cost will be somewhere around $10 billion to $100 billion. So it's a mega project. It involves a lot of investment in this project, a lot of work in this project, a lot of disciplines in this project. Another feature of this high-speed rail construction is it's a linear construction. It's always around a corridor. It's around a corridor which connects point A to point B. So it's a linear construction. It's a linear construction which later on the operation will be start from one end to the other end. And the distance could be like what we said, 200 kilometer to 500 kilometer in length. So that's a linear construction feature is also one of the special characteristics of the high-speed rail system. The third one is the schedule. The schedule is tight. Why is that? Basically, it's because of your investment. The investment of 10 billion to 100 billion, the interest will be a lot. If it's a 10 billion project, interest could be something like $1 million per day. 100 million, the interest will be $10 million per day. So with this kind of the interest per day, this construction schedule had to be very well calculated, well managed. So every day is a lot of money. Schedule control is very important. Then another another characteristic is the safety tolerance for high-speed rail system is very narrow or almost zero. There is no tolerance for any sloppy work for a high-speed rail system. So you have to fulfill this kind of safety requirement with good quality. So good quality is important in order to maintain the system safe. Another special characteristics is it's a mega project. It involves many disciplines, and all these disciplines have to be integrated at the end of the project to make the system work. So it's a complicated integration process. You have to integrate different disciplines and making sure the interface work well. And that is the characteristic of these projects. Now let's look at what we need to construct. What are the objects? What are the objects you have to construct? Let's look at the infrastructure side. What are the infrastructure you have to construct in order to make a high-speed rail system a system? Basically, we divide them into 5 groups. One is called core system. One is the track work, which support the train and the other signaling communication. This is the track work. And then the other system which is supporting the track is the civil work. And then there are stations for service your passenger and depot for service your trains. So these are basically the 5 subsystems. The 5 subsystems of high-speed rail which you have to construct. Okay, taking the core system. In the subject today, we will not talk about a train because the train usually are manufactured by the supplier. Okay, so that's not including the construction of the train in today's subject. Our subject today will be the other core system which is supporting the train. And that will be what? First one, of course, is the power feeding system. How do you feed the power into a train? And that is the power feeding system. Then second is the signaling system, which you control the operation of the train. So the signaling system will be the second part. And then the third part will be communication and controlling system. How you can control this train, how you communicate with the driver and the passengers and the train attendant. So these are the following system. And then you have some wayside equipment, warning system, E&M, telephone along the wayside. So this would be all the other system which is supporting the running of the train, and also called a core system, which is sort of E&M type of the construction related to supporting the train. So these are the core systems. Then following that is all this had to running on the track. Okay, the train had to running on the track. So there would be the track work which you had to build to support the operation of the train. And then it's the civil work. You support the track work, okay, to keep the track in place, to keep the track from being interfere from outside. Okay, so this is the civil work which you got to construct to support the track work. And then following that will be the stations. The stations will be isolated in different spots which you provide the service to your customer. And then the depot will be often be at the both end of the line and to provide the service to the train and also the stabling of the train during the evening. Okay, so this is the type of the infrastructure you constructed in order to support the train operation and supporting the high-speed rail operation. Now, let's look at all this infrastructure need to be constructed. They also have some difference. Most of them are linear type of construction. They construct around the alignment. They construct from point A to point B. They also can be constructed in segments. So you can divide the whole alignment into segments, and so you can have different work sites to start construction, and therefore different construction phases. Okay, and your progress will depend on how many work phases you have. You can put in and economically put in or reasonably put in, and then that determines how long your construction will be, progress of your construction. Okay, so you have to set up work site to accommodate this work phase become a starting point for the work phase. Okay, so for this linear construction, you have to select the work site for this. And then, even in the same work phase, you can have several activities concurrently happen. You can have some activity at the beginning of the work team, and then you can have some activity follow that, okay, and then try to become a game, a work game, which has, for instance, like the track laying at the beginning, power line laying at the second game, and so on and so forth, and becoming a work team, concurrently constructing the work. Okay, so the total program of a high-speed rail construction will depend on how you arrange this sequence and how you arrange your work site and how you arrange the concurrent process, and that determines the construction schedule. We will illustrate all this in the later part of today's lecture. And then there are staging and depot. These are fixed at some location. They constructed within a boundary, and they might go upward as a several-story building in order to accommodate all the facility in there. Their progress is more dependent on this vertical arrangement after the construction. So these are the kind of two types of the construction, but majorly, I would say all the construction, 90% are linear. This would be about 10% of the cost, somewhere along that range. Okay, the sequence. Because of this linear feature, there are actually some sequence for this construction. Our design is from the train, and then the core system which is supporting the train, and then the track work, and then the civil work which is supporting the track work. So that is the design sequence. However, in construction, it's reversed. In construction, you start with the civil work which support the track work, which support the power system, which is supporting the train. Okay, so it's building from the bottom up. In design, you consider it from the train, it's the top down. And in construction civil work, you from the bottom up. So that is the construction and design are different sequence. Okay. So in arranging your construction sequence, you have to start with civil work, track work, power, signal, communication, and wayside. Okay. So these are the kind of the sequence you try to arrange in order to construct your work. station and depot can be planned independently to fit into the total schedule.